All right, let's look at our different forms of quadratics. So a lot of this is going to be review. Some of it, this chapter is going to be adding on to what you did before. One thing that's nice is when you get to pre-cal, you get to start sketching graphs. So sketching a graph means you don't have to find every single piece. You just have to have enough information to make an accurate graph. So I'm going to go ahead and make my graph over here to get ready to plot on it. Okay, so we need to find a couple pieces. Now, the first piece that we always find with quadratics is your vertex. The vertex is extremely important because the rest of the graph comes off of that. So with our vertex, if you remember back to Algebra 1 and 2, to find it, you do the opposite of b over 2a, and then you plug it in. So let's do that. The opposite of b would be a positive 4 over 2 times, there's a 1 in front of the x squared, so 1. 2 times 1 is 2. 4 divided by 2 is 2. So there's your x value of your vertex. Now I'm going to plug that 2 in for my x's to find my y. So we have 2 squared minus 4 times 2 plus 7. 2 squared is 4. 4 times 2 is 8, and then plus 7. 4 minus 8 is negative 4. Negative 4 plus 7 would be 3. So there's your y value. Let's go ahead and plot that on the graph. Okay, so there's my vertex. Now remember, with your vertex is also your axis of symmetry. So you actually have a dotted line going through the vertex right there. That dotted line is called your axis of symmetry. So if you folded your paper on that dotted line, both sides of the graph should line up. And that's always an x value, x equals, because it's an up and down line. So now let's find our other pieces. Probably the easiest piece to find is going to be your y-intercept. So to find your y-intercept, you can plug in 0 for x. So we have y equals 0 squared minus 4 times 0 plus 7. Well, what happens? 0 squared is 0, 4 times 0 is 0, so you're just left with 7. And that's your y-intercept. Remember, your c value was always your y-intercept when we learned this the first time. 1, 2, 3, 4, 5, 6, 7. So put a dot there. Now, remember, a parabola is a U or a hill, and they're symmetric on each side of that axis of symmetry. So I can actually count to find my last point. This y-intercept is 1, 2 away from the axis of symmetry, which means I go 1, 2 away on the other side. And I can make my parabola. Okay, you can always use a t-chart. Okay, if we did when in doubt, t it out, and we plugged in some numbers here after finding our vertex. Let's say we plug in 1 and 3. If I plug in 1, we would get 1 squared is 1, minus 4 times 1 is 4, plus 7. So negative 3 plus 7 would be 4. And then if I plug in 3, I get 9 minus 12 plus 7, which is also 4. And if you notice on the graph, there's that point and there's that point. So you would have got the same thing. Okay, so there's your graph sketched. Now, we also have vertex form. Remember, vertex form looks like this. From this form, you can pull out your vertex directly from this form. If it is in this setup, you can pull out your vertex by having HK. All right, now let's come down here and do one. So from this vertex, notice at the top, the K should be subtracted and the H should be subtracted. So be very careful with that because we're actually pulling out the opposite signs as long as the K is on the same side with Y. So my vertex for this one, that's where I'm going to start, is negative 2, because that should be a minus. So to make that a minus, remember double negative, minus minus becomes a plus. And then this should also be a minus. So negative 2, negative 7. So I'm going to go ahead and plot that. Remember, that also gives me my lovely axis of symmetry. So let's just find our y-intercept again. So what do we plug in for a y-intercept? Oops, this should not be an A. For a y-intercept, let's make it a 2. For a y-intercept, we're going to plug in 0 for x. So I have y plus 7 equals 2 times 0 plus 2 squared. So I'm solving for my y int. So what does that give us? Y plus 7 equals 2 times something. 0 plus 2 is 2. 2 squared is 4. 2 times 4 is 8. Subtract that 7 over, and our y int is 1, which is the point 0, 1. So I'm going to go to 0 and up 1. Remember, you are absolutely welcome to just count to get that last point, which would be this guy is 1, 2 away from the dotted line. So I go 1, 2 away on the other side, put my point, and there's your parabola. Now the last form is intercept form. This is when it's already technically factored for you, is kind of how I look at that. So factored for me means I'm going to pull these guys out, and I'm going to set each one equal to 0. Just like they were my factors. So this would x would equal r sub 1, and this one x would equal r sub 2, which means there's 2 of my points. Those are my x-intercepts. So I have r1, 0, and r2, 0. So those are my x-intercepts, and my axis of symmetry is in the middle of those. Okay, so let's try one. So down here, sketch the graph. So I have x plus 1 and x plus 2. So I'm going to take each of those to find my x-ints first. Set them equal to 0. And solve. Minus 1. And then minus 2. Remember, these are x-intercepts, which means we have them on the x-axis. So our y value is 0. So we can go ahead and sketch those two. -1, -2. Now, our parabola should be symmetric, right? So my axis of symmetry should go right between my x-intercepts. Well, this one, yeah, you could count. If you can't count, you can always average them. So -1, so this is finding vertex, -1 plus -2 divided by 2. -1 plus -2 is -3 divided by 2 is -1.5, which is right here where our dotted line is. Then I can figure out how far we go up and down by plugging that in. So we have y equals -1.5 plus 1 times -1.5 plus 2. So -1.5 plus 1, watch your negatives on this. -1.5 plus 1 would be -0.5. And then -1.5 plus 2 would be +0.5. So we're going to multiply those together to get 0.25, and that would be negative. So my vertex is at -1.5 and then down 0.25, which is going to be really hard to put on there, but just put it right up there. And there's your graph. Now, you could have always found our y-intercept, right? What do we plug in for 0 for our y-intercept? We plug in. What do we plug in for x for our y-intercept? We plug in 0. So for our y-int, let's just check our work here. Our y-int, I could plug in 0 to get 0 plus 1, 0 plus 2. So 1 times 2 is 2. So that would be up here, which works nicely on that graph. And then I could count to get my mirror